So the green engine we're seeing here is a 1912 Lauson Frost King made in New Holstein, Wisconsin. The engine feature this year for the New York Steam Engine Association is engines built in the state of Wisconsin. So anywhere you see the orange placards, those are the feature placards, and that will indicate an engine built in Wisconsin. So here we have the 1912 Lauson Frost King, 6 horsepower. The Frost King name comes from the ability of the engine to start readily in cold weather. And an interesting contrast, this little lawnmower has an engine built by the Lauson Corporation starting in the mid-50s. So the same company that built this green engine in 1912 and that red engine over there in 1924-25 time period, by the 1950s was building the then modern air-cooled lawnmower type engines. And this particular one you see on this mower is their first all aluminum block air-cooled lawnmower engine. This Lauson continued to build engines under the Tecumseh Products Company name right up until 2008, when Tecumseh Products Company exited the small engine business. So this engine is also a Lauson engine, but not sold under the Frost King name. The tags you're seeing in Eric's video show the Alpha name, and this engine was sold by the De Laval Dairy Supply Company. De Laval sold a lot of Lauson-built engines with the Alpha name on them, but it is indeed an engine built by the John Lauson Manufacturing Company in New Holstein, Wisconsin. This particular engine was built in the 1924 to 25 time period, and by then Lauson had introduced 3 sizes of these engines with the disc or solid flywheels. So they built a 1.5 horsepower, 2.5, which this one is, and a 3.5 horsepower size. So this restoration was done by somebody else. The engine was mostly in this shape when I acquired it, and with just some checks, cleaning of the grease cups, and a couple of other small changes, it was ready to run. I do it about every 45 minutes or so. I mean, there are many different manual oiling points on the engines.
Okay.
Like all the motion pins, etc., for the rocker arm, for the governor linkage. But there, I just re-oiled those a few minutes ago.
Okay.
Now needed to hit the valve stems. So, notice the ignition system on this Lauson engine and that one. Instead of a spark plug with a high tension magneto, these have what's called an igniter. And they use a low tension magneto to provide voltage to the igniter. The igniter is a set of breaker points within the combustion system.
Okay.
So at the right time, the cam is a 2-lobe cam. The first lobe trips the igniter at the correct time to cause spark to ignite the air-fuel mixture. And then at the correct instant following that, the exhaust lobe opens the exhaust valve. So the firing and coasting is a type of speed governor called hit and miss governor. It's an interruption of the 4-stroke cycle of working events. So it's a conventional 4-stroke cycle engine, but with the governor interrupting the sequence of events to control the engine speed. I can put a little bit of a load on it. You can hear it fire more frequently. But you hear how the coast period became shorter as it took that load.
Hooked up pretty quick on
Right,
it too. It didn't
right,
take long.
right. Yeah, it's a regular centrifugal weight type governor that controls the linkage that locks the exhaust valve open. Now, depending if you can zoom in, that's a Lauson engine in that corner belonging to Jeff Holmes. And Jeff's engine has a high tension magneto and a spark plug. So it's a later engine, but it's a W series, again with the solid flywheels. But somewhere around 1925, Lauson changed these engines from the low tension igniter system to the high tension Wico EK magneto with a spark plug. So that's the brass colored box on the side of that engine of Jeff's. This is a high tension magneto. But you can see here the high tension magneto and a regular spark plug lead, and then the spark plug here in the cylinder head. And this is a fairly late version of this Lauson engine. This particular one was made in the early to mid 1930s. Lauson made this style of engine up until around 1942, and by then they were making several different models of other air and water cooled, more typical of the engines we see today. That has a Lansing company nameplate. This particular engine was used in a Lansing cement mixer, but over here down on the side it has the Lauson nameplate right down there.
Now, what do you guys use to put in the oilers?
Well, I like to use straight 30 weight SAE oil, but it's not real critical with these engines since it's a total loss oiling system. One other point to be made about my engines here, you'll notice they're not running on gasoline. And generally, the engine builders back then had fuel systems available for both natural gas fuel and gasoline fuel. So these are burning propane gas right now using a modern small engine demand regulator, which does not let fuel flow until a vacuum signal from the carburetor pulls the regulator open. The original versions had a carburetor with a valve in the carburetor that would stop the gas flow when gaseous fuels were used.
Hello, everybody. This is a 1928
Well,
Lauson.
the governor weight on this
2.5 horse
inside the
engine.
flywheel,
It's a hit and
see
miss.
it with the engine running.
It's fired with a magneto. It sends the spark plug
but
to give it fire.
Single centrifugal
And this
weight
engine came out of a
swings
cement
out this
mixer,
way,
and I believe it was made in
a ramp type
Wisconsin.
collar when the weight
That's a
swings
feature
out.
this year at Canadaigua Steam
latch in
Pageant.
the detent there.
It's a pretty good running engine.
That weight.
As you can see up close, the piston and everything, how it runs into the
so
hopper.
The spring is what sets the engine speed. So
quite a piece of machinery made, considering what the guys had back in the day.
Weight once flame liquor engine. So this is an external combustion engine that operates based on a temperature and pressure differential across the cylinder. It actually inhales that flame that you see burning on the alcohol burner, and that establishes a differential of pressure and temperature across that cylinder that is then the motive force to keep the engine running. So it has to warm up a little bit. You can see Will is cranking it, and when the right temperature conditions are reached, it will continue to run, but it is not running with combustion of air and fuel inside of that cylinder. So it is not an internal combustion engine. Light on, light on.